All right, so here's my most difficult angle relationship example. I got this like star looking thing and a couple givens over here. All the lines show here intersect at point G. Okay, all lines are coplanar. That's just so that to be crystal clear about these things, like line, for instance, line CF isn't on a different plane, it's on the same plane, which happens to be this piece of paper. And ray CG, this should actually be ray GC. Let me fix that. Ray GC bisects angle BGD. Angle BGD. Okay, so what can I deduce from that given information? I also have this little angle measure stuck over here in the corner. Okay, so let me go ahead and write down anything that I can deduce from here. Okay, all lines, as well, it says all of these are straight angles, right? So I'm gonna go ahead and write that, right? I'm gonna say that angle AGD, comma, angle BGE, comma, and angle CGF are straight angles. Okay, I normally don't give my Greek letters to straight angles because straight angles are just pretty basic at this point. All right, so this is given to me. Okay, so now I'm going to say that the measure of angles ACD, angle BGE, and angle CGF are 180 degrees, or is, I guess, because all those are the same angle, is 180 degrees. So that's 180 degrees, that's 180 degrees, and that's 180 degrees. From here to here, from here to here, and from here to here. Okay? So that's some pretty important foundational stuff to lay down first. Okay, and then I have this, I'm going to call this angle theta. I'm going to call this angle lambda. I'll call this angle gamma. And let's see what we can do with that so far. All right. So, what are some relationships here? Okay. Well, I also have this another angle here, angle BGD. I'm gonna make it green. From here to here, I'm gonna call that epsilon. This angle epsilon, right? That's a combination of angle lambda and angle gamma, right? If I add those two together, whatever they may be, it's going to equal that. So I might as well write that down. Might as well write that down. Maybe it'll be useful, maybe it won't. Lambda plus gamma equals epsilon. Cool. I notice I'm only really dealing with the top half of this like figure. And there's a reason for that. Well, I'll show you what that is, I guess right now. Okay, so let's write our first relationship statement. What if I didn't have angle CF right here? Okay, what would that tell me? Well, it tells me a couple things. Right, if I had just ignore angle ray GC and ignore ray GF, right? What does that tell me? Okay, well, I know that when I have just intersection of two lines, that the angles opposite of the vertices are the same. Those are called vertical angles. Vertices, they're vertical angles, right? So this is also gamma. Okay, so how do I say that, right? I'm going to say that angle gamma is congruent to angle GDE because vertical angles are congruent. Therefore, angle GDE equals 45 degrees. That's the definition of congruence, right? So this is 45 degrees. Awesome. So what about angle epsilon? Can I figure out what angle epsilon is? There's two ways I could figure this out, right? I could use angle addition postulate, or I could recognize that that straight line with that ray coming up here makes a linear pair because a intersecting lines like that make vertical angles and linear pairs. Okay, so here I'm going to say angle epsilon, just makes it easy, is going to be equal to 180 degrees minus angle gamma, right? Because linear pairs are supplementary. Or maybe I should have written down here earlier that angle gamma and angle epsilon are a linear pair. All right, I'll write that down just to establish that. Zoom out a little. Manually zoom out. Okay? Right, because it's definition of linear pair. I'll write that down right there. Okay, and linear pair is supplementary, so I can go ahead and put that in there. So then now I can say that epsilon equals 180 degrees, 180 degrees minus 45 degrees, which equals 135 degrees. Let's make that green. Make this green. 135 degrees. Okay, so if angle epsilon is 135 degrees, okay, what does this angle measure equal from here to here? Again, ignoring this line, right? Ignoring that line. Those are vertical angles. So this is epsilon, right? So I can say that angle epsilon is congruent to angle, what is it? AGE, because it's a vertical angle. So I can say that angle AGE equals 135 degrees. Cool. All right, so I'm almost unraveled all this stuff. So what this is saying is the same thing as I got on the bottom of this line is a mirror image of what I got on the top of this line, right? If you see what that's going on here. So this is gamma, and this is lambda, right? And hey, look, they're also vertical angles. If you ignored that line, well, I guess if you ignored that line, they're vertical angles. Kind of, not really. They're part of a vertical angle. Okay, but anyway, so I can now say, and they also bisect each other, right? So CG bisects epsilon, right? Which BG, which is what I named epsilon. Okay, so those are the angles up there. They bisect angle epsilon. Okay, so now I'm gonna go ahead and deduce. What does bisect mean? That means that gamma and lambda, so that's lambda, that they have the same angle. They're the same angle, right? Can't see what I'm doing. Let me zoom out some more. Those angles are the same, because that's what a definition of an angle bisector are, right? Because the definition of angle bisector. Okay, so now I'm just going to go ahead and get rid of my gammas, or my lambdas, and change them into gammas. Cool. So up here, I can change that into a gamma as well, right? This was angle addition, by the way. I didn't put that over there because I wanted to give myself some space to be able to say that, and what is gamma plus gamma? Well, that's 2 gamma. All right, so if I want to solve for what a gamma is, I gotta take epsilon and divide it by 2, right? So I'm gonna take epsilon, divided by 2 equals gamma, which equals 135 degrees divided by 2, which is 135 divided by 2. We have 67.5 degrees. 67.5 degrees. 67.5 plus 67.5 is 135, plus 45 is 180. 180 on this side, 180 on this side is 360 degrees, and it comes full circle. So that's a good one. I like that one. That was fun, right? Seems like it's a lot of complicated writing, right? But this is to get you in the mindset of doing proofs later, right? You have to prove these things with what you know, and I want you to be able to practice doing it this way, because you have to justify everything that you do. Okay, if you want to put it in a table form, that helps too. All right, hopefully that was as fun for you as it was for me.